Hello, I am Karim Khaled Nouman and this Plaxis 2D 3D course. Chapter 5 Slope Stability. Slope stability. They are slopes that made by nature and made by man-made. So, stable. Number 2, cohesion of soil. C. We can find the angle of internal friction in sand soil. We can find cohesion in clay soil. Forces causing failure: surcharge, seepage, gravity force of soil, earthquake. Modes of failure: gamma submerged over gamma saturated at its equal 0.7 unsafe. And that is another example. Stability analysis of finite slopes, a circular ARC method. For clay soil, we can find factor of safety equal resistant moment over driving moment. Resistant moment equal Cu cross L arc cross radius. Driving moment equal W cross X. W mean weight, the weight of soil. X is and divided the resistance force over driving force. This is the example that I modeled it in Plaxis 2D. Design of slopes stability using Plaxis. Soil profile: we have one layer as follow. The thickness of layer the type of soil is clay. Thickness of layer equal 25 meter. Angle of internal friction equal 30 degree. Cohesion equal 7.5 kilopascal. Modulus of elasticity equal 25.00. Water level: there is no water level. Distribution load equal 0. There is no distribution loss. System is slope stability. The required is total displacement. So we will open Plaxis 2D. The title is Slope Stability. Okay. Model: plane strain, elements 1.5 newt, dimension length meter, force in kilonewton, time in day, lift minus 20, right, we remain at 50, bottom minus 1.5, and top we remain at 25, and press OK. So from here, the thickness of slope stability equal 25. Okay, just here to -5, this coordinate. We will go to the width of slope stability. It's equal from here 7.5 here 30. This thickness equal 7 meter. So we will move to this distance. It's equal 1.7 We want to know the total of displacement. This is deformity shape and this is total displacement. It's equal 3 to 9.48 e minus 3. Okay, it's equal 0.3 meter. 0.3 meter.